last topic in the topic of capacitor. That means the energy stored. How much energy is stored? Is stored in a capacitor. Energy stored in a capacitor. So the energy will be stored in the form of electric potential energy. Let us see how. So when you apply certain potential, let us say potential V across the capacitor, the charge goes on increasing. The charge increase from 0 to, initially when you do not apply the charge, although two plates are there, if you do not apply the potential, charges will not be there. When you apply the potential, charge will develop. The charge develops from 0 to Q. After increasing the potential from 0 to V. So V is the applied potential, charge increases from 0 to Q. Right. Then, by definition of capacitance, this C will be equal to, what is Q? Q is the final charge. What is 0? 0 is the initial charge. Then charge Q at any instant, when charge increases from 0 to Q, let this Q be the charge that represents when it increases from 0 to Q. 0 the Q was that at any instant the charge Q though C or and it is not equal to the total charge. C marks the label any value do then this will be charge Q divided by potential V. So this is from the definition of capacitance. Then let us try to find the small work done, dW. In charging the capacitor, dW say charge of the changadeva work done to kya V dQ tani. What is dW? dW is the work done in charging the capacitor by dQ. dQ say increase of the changadeva work done to dW is name. This comes from the definition of potential difference. Potential difference is work done by charge. So, if you want to find work done from here, it should be the product of potential into charge. This is what is being happened here. Potential into charge. Let us find V from here. V this will be Q by C. Okay. Then this will be how much? dW will be how much? V ki mota karisanjalani Q by C dQ. This is the small work done. Karamba work done in charging the capacitor by dQ. dQ have amount of charge stored to bukanda darkar hoga do work done dili si. Koi na pa misi kalino. Energy putok pa is work done putok dini. As you know by work energy theorem, your work done is equal to change in kinetic energy. It may be kinetic energy or potential energy. By conservation of energy. Then, work done say, small work done say total work done. Total work done. Work done in charging the capacitor from 0 to Q say. You will use the concept of integration. W is integration is equal to integration dW. dW Q by C dQ tare. Then this will be how much? Q by C dQ. Charge varies from which amount? 0 to Q natra. Initial charge Q, initial charge 0, total charge, final charge Q. So this much is the total work done. Then what I have just done here, I have just substituted value of dW from here, then substituted the limit. Because why I am substituting the limit? Because the capacitor is being charged from chargeless to total charge Q. That's why the lower limit should be 0, upper limit should be capital Q. Let us apply the first few rules of the integration ki rule khara policy. So when you have any constant, that constant should be taken outside the integration. That is the first rule of integration. So this will be q dq 0 to q. I have taken this 1 by c outside the integration. Let us apply integration x power n rule, x power n dx. X power n plus 1 divided by n plus 1. So instead of x you have q here, instead of n you have 1. Q dq ni laido, q power 1 plus 1 di q square lani, makada 1 plus 1 ni tani 2 tani. So this will be 1 by c, then q square by 2, lower limit 0, upper limit q. Let us substitute the limit now. Limit substitution when you apply the integration. First limit, say upper limit, say substitute 1 by 2 q square by c tarni. Lower limit in the 0 to 0 minus lower limit in the 0 square 0 second. So this was the work done that you have obtained, and you will say this work done W will be stored as the potential energy, electric potential energy U. So the potential energy which is stored in the capacitor, electric potential energy electric potential energy which is stored in the capacitor, this U should be now equal to half q square by c. So this is one of the ways to represent the electrical energy which is stored in the capacitor. Now there are another 2 ways of representing the energy stored. Let us see how. See, this is the first formula for energy stored in the capacitor. Then what? Your C is equal to Q by V. This is from the definition of, let us take the capacitance at the final instant. That's why you are using capital Q and capital V. Then equation number 1 U should be how much? Half Q square like that. C Q by V. Q cancel sakrani. So your potential U is how much then? Half Q into V. So this is the second expression for energy stored. Second expression. First expression is Q square by C, and second expression is half QV. Is that okay? Then let us come to another one then. Makhadang lase. Asidagi, from the same formula, if you want to find Q, sidagi Q puthodi kay tani. Q puthodi C into V tani. Right? C into V. So instead of Q here, which is here, let us substitute by CV. Look at that. Half CV into V. Q is what kind of CV na. Aditagari CV into V di kya tare? Itani CV square. So this is yet another formula for energy stored in the charge capacitor. So you have 3 formula now. Half Q square by C, first formula. Second formula is half QE, and third formula is half CV square. Aduna problem amada karigumba Q ga C ga piramaga energy puthwai ta C sinarani. Atopa problem da karigumba Q ga V ga piram ta gana C formula sinarani. Karigumba C ga V ga piram ta gana homzo formula sinarani. Depending on the condition which is given in the problem, you are going to use either of these 3 formula. And masi high energy source karam form the store that we had it is stored in the form of electrical potential energy between the 2 plates. Plate 2 plate not beyond. Right? So this is the